Hi everyone, this is Dr. Sheets. Hope you're having a good day. Today I'm going to talk about Chapter 14, Database Connectivity and Web Technologies. And really what this mostly is about how we connect our applications to our databases, and then how we share information among our applications or among applications from different organizations. And so I think it's a really important topic because most or many of our systems today are built over web technologies, even if it's a system that's not going to be open to the public. Within our own infrastructures of our organizations today, we are built over top of web-based technologies, and it's very powerful. It's very important in terms of being able to distribute our systems and things. So it's well worth your time to learn about how to connect a web page to a database. And so we'll go over some of the different approaches, the different technologies. They're very similar. You're going to either pass an SQL statement, or you're going to give a table and column kind of reference or attribute reference and say what you want to do. If you want to insert a record, add a record, you're going to use cursors in terms of queries to get your data from the database and process it in your web application. We'll talk a little bit about what kind of services are provided by web applications, and they can be anything. It's really where the future is. And then we'll talk about sharing information among organizations with XML, and that's something that is a way of representing data that the metadata is right there with the data itself, or in a very similar perspective, so that you have both the definition of the data and the data. And then we'll talk for a little bit about cloud computing at the very high level. Well, so database connectivity is about having middleware that lives between the program and the database or the data repository, and then having the way to access that data through any type of programming language or any way that is needed. This idea of universal data access, that's what we are providing. And so our middleware is this software that sits between the application, where the application knows what tables it needs and what database it wants to connect to, but it doesn't know where it is on the computer, or doesn't have any of the details to get to the actual information. And so what the middleware does is it connects up what the application knows to what the RDBMS needs to know to be able to find the right result set and return it. And that's what the middleware is about. Well, native SQL connectivity is when you have a product like Oracle, and what they provide is a listener. And that listener is a service that runs on your computer and listens to a particular port on the computer. And then whenever you want to get the response to a query, you send the query as part of an object to that port, and then the listener recognizes it, then passes it on to Oracle, processes it, sends it on to Oracle, our DBMS on your computer, which then accesses the actual database and then returns the result set, which is then returned to you. And of course, it doesn't have to be on your computer. It's probably actually not going to be on your computer most situations. And so these interfaces are optimized, and usually When we finished our app, it ran for over a decade on Oracle. Just had to be upgraded every so often. When if Oracle had something that wasn't backward compatible, we had to make some changes. But once it was installed, so I don't really see this as any big hassle for the programmer. But in the way the world has evolved, it's definitely more clunky, you might say, than smooth as some of the other approaches might be described. Well, open database connectivity is the way that we used in our online survey system to connect to the database in Microsoft Access. And so what you do is you go into the control panel, and you'll find under administrative tools, you'll find a panel called ODBC administration. And in there, you can set up these your database so that it can be accessed by your program through this ODBC bridge. And that's what we call it. It's the bridge to get data from the program to the RDBMS and back. Well, data access objects are an object-oriented way to try to get at this data, where you give it a table name and attributes, or an object or class attributes, and get your data from that perspective. It's more of a program-oriented perspective than a relational database-oriented perspective. And you can make these calls from Visual Basic, a number of different other tools, also from Access. The idea is that you can use it to access relational resources, but you don't have to do it in a relational way. Well, remote data objects are just sort of a higher concept of that idea of an encapsulated object that is not necessarily relational, but the elements that are part of this object are relational. And so what essentially happens is the middleware takes the relational table and columns and rows and forms that into an object and returns an object at that high level. So instead of having a result set, you have a collection of rows, which is, no different than a result set. It's just a different way of thinking about it and a different way of managing it in your program. And then dynamic link libraries are the way these systems are implemented, because it makes for a more efficient processing through the operating system, and it's a very efficient process. But we've learned how important the disk is and how important performance is. It's good that it's been worked out to be a highly efficient process, because it has to be to keep users happy. Well, here's just sort of a high level representation of the things that we've been saying. Is that these are all the middle levels. I'll go with orange for hokey, even though we haven't been doing that great. Anyhow, so this is the middleware part that connects up the application that is up here. Right here we have Access, and this is where you're not using Access tables in Access. You're using forms or queries, things like that stored in Access, and you're going through this ODBC bridge, and you're passing in some sort of SQL statement or something. And then there is a depending on what database you're going to, there's different drivers. There's an Oracle driver, which really connects to that Oracle listener that I mentioned before. There's the ODBC driver for access, which is one that I've used the most in the systems that I've developed around the university or in my research processes. Then a parallel track is the remote data objects, and then they are built on top of data access objects. But then there's the jet engine that takes these things and turns them into SQL, which is needed for MS Access. Well, so the ODBC is made up of a number of pieces. First is the high-level API through which things are passed. On the online survey system, we pass through essentially just SQL strings. And then the driver that is in the reference in the ODBC entry that directs it to the particular database, right? There's a driver for each type of DBMS, right? And we use the Microsoft Access driver because that's the DBMS that we use for the online survey system. So here is the basic what the form looks like when you get into. So if you go to your control panel, then you go to administrative tools, and then you pick the ODBC data source administrator, this is the first screen that you will see. And here we have an entry for the Gridora, right? And it's an Oracle Client 11A. So if we come down, now if we click on that, we come down and we see that there is the name, and what we're getting here is an Oracle TNS listener, right? And so there's a program running on our machine that is named Gridora, and it is an Oracle listener. And what that listener is waiting for is for some application to send a message to it so that it can respond, and that message will have some sort of SQL statement embedded within it. And so what we're gonna want to know is, where is this database, right? And all that stuff is contained within the listener itself. So here, all we're doing is connecting the program. So in our program, we're going to refer to this entry here in the ODBC, this Gridora, and then that Gridora is going to then send whatever we send to it along to this listener Gridora. Now, if this was an MS Access screen, what we would see here is which database on our system that we want to attach it to, right? There'd be some MDB file, or now in the 2013 or 10 version, the AACDB file. Okay, let's see. Oops. Here we have an example of how Excel uses ODBC to connect to an Oracle database. So in this way, you're going to run a wizard inside of Excel up here. And it's going to ask you to select the data source. And when you select Gridora here, then you're going to have to go fill in the ODBC, the username, and the password. And then once you do that, then the data that are available, what tables there are, and then what attributes there are for the table for you to pick from, are presented. And then those things come from the database, Gridora. So that was one hit to the database to get the things that you can look at. Then the wizard asks you to pick the ones that you want to see, and then finally return those to your data file here. And that just gives you an idea so that what happened here is that the messages came in down to the server and back. So the ODBC, first thing it said, well, here, this is the database I'm connecting to. What tables are in it? And then that came back. And then it asked, okay, I want these tables. And then comes back the actual result set down here. And then the first thing that came back, remember these were things in. But the first thing that came back was the list here of all the tables, names, and the attributes. So that gives you sort of an idea of what the middleware does, what the ODBC is about, is connecting to the actual database. These things are all part of the wizard. Let's see. Let me erase my inky. Right? All those are part of the wizard, right? But it still takes those two. It takes this, the connection to the database, and then the return through the server, and all the way up through the ODBC actually, of the tables. And then once the query's finished, then back up through and down through, and then back up through and down to the actual rows in the table. Well, object linking and embedding is the sort of the way that you try to connect object-oriented programs to our relational databases. And so what it is a set of objects that programs can use that take database functionality and turn it into another perspective that is more consistent with an object-oriented programming perspective of the world. And I think it makes sense, and it works fine. But it's just not a real data person's perspective. It divides the world into consumers of information and providers of information. Now it makes logical sense, right? And then as a designer, now we are doing both sides, of course. We are writing our program that consumes our information, and then we are also on the database side as providers. And it's primarily for C++, Smalltalk, other object-oriented programming languages. Well, ActiveX data objects are another way of implementing the embedded objects, another OO type of interface. And the idea is that it doesn't have to be only OO languages that access data objects in this way, and with our embedded objects, we might as well make it accessible to other languages. Well, so here's the overall idea. It's very similar. We have our clients, which are consumers. And then we have our providers, which really are different types of databases, right? We might have Oracle, we might have email from Microsoft Exchange. We might have a SQL Server. We may have a direct ODBC to Microsoft Access. And so what these providers are doing is this layer is given these abilities that you would expect to have in any application. And the different, and that are things like cursor processing, writing a query. I mean, you need to be able to bring a result of a query into your program and step through it one at a time. And so that's the basic capabilities that are provided, and then that makes the application simpler, right? And the big thing about this is that you're usually using some program. I mean, and if you are using some programming language to write your own unique system, if you are using Access or Excel, it's just as a front end to be able to make the user interface something that users are comfortable with already, right? That's why you would want to use an Excel interface or an Access interface as your client application. You wouldn't necessarily be storing your data in Access or Excel. You'd be getting your data from your data providers, but it would give you a way to make an interface that is familiar to your user. Well, Active Data Objects as the .NET framework, it fits right into their development. It allows programs that are written in any language are consistent. They have their own C# language in the .NET framework. It's an object-oriented language. They also allow Visual Basic access. It's a way of thinking and aligning the data consistent with a database that is underlaid by XML. And so they store their data in an XML format and then keep their persistence in that format too. So it's all text-based. It's a sort of a simplified process of maintaining data, but it is more consistent with a programming approach, and using the XML makes it more transferable and more extendable. We'll learn more about XML here toward the end of our presentation today. Well, so the idea is that you're going to take what comes from the database and you're going to put it into a format that is easier for programmers, object-oriented programmers, to understand, to make it more consistent with the way programmers look at the world than the way database people look at the world. And so what they're saying is we don't want to really understand database concepts. We don't want to understand SQL. We would like the data in a format that fits our application so that we don't have to think about new ideas when we process it. Now, I'm not sure that came out exactly how I intended because it sounded somewhat negative, but I didn't really mean it that way, right? But what makes sense in object-oriented programming is your database is just a collection of tables. No problem, right? We have this collection. Anytime we want to find a particular table, we just sort through that collection till we find that table. Well, and so then each table is really just a collection of columns, right? All the different attributes that describe a table, which I can trace through in a list. And all of the data rows as a collection, all the rows that are in that table. So then I can take my data columns and parse my data rows to get to any particular instance in that data row that I need to. Like if I want to do a key comparison, I can run through and look at all the keys for all of the row collection that I have. It's very easy for me to fit into my understanding of programming. And that's why people like it. So then there may be some attributes, some constraints among the attributes, or constraints usually on the attributes. And then the relational database constraints are just another set of constraints that apply to the tables. So it's a different way of looking at your relational database as a program. But one thing I think is powerful is that even though this has no relation to the semantics of the problem and things like that, it's still your database will still be better and can easily be transformed from the beautiful semantic model that we created into something simpler like this for non-data thinkers. Yeah, that is negative, isn't it? Sorry, programmer guys. Hey, I was a programmer guy. I still write a lot of programmer, but I think you got to think from a data person perspective when you're writing your program. See, I would never have classes like this in my program, right? With a data table and a collection of rows and columns. Think about this. I'd have real classes. I'd have a customer class and stuff like that. So, three-tier architecture stuff that I'm sure you learned in software engineering. So, JDBC is the way you connect your Java programs to ODBC. And then, of course, ODBC connects you to the actual DBMS and then also the actual data itself. Well, in JDBC, what you do is you have a program, and what we did is we had a program running on a server, and I guess we'll get to that in a minute. So the advantages is that if you already are programming in Java, it makes it very easy to connect up your database. You embed your SQL right in their Java so that it makes it very simple. The things that you're already very used to doing in your programs, everything still works the same way. And then it just connects right through the ODBC driver to the actual DBMS. So here's our little picture of the idea of the JDBC. And so what we did is we had a called a group cognitive mapping system, and it was a Java application that ran on our server. And so what it did is it had inside the application, it had the SQL necessary to access we had a Microsoft Access database. And so what we did was we had our Java application, and it used the JDBC ODC bridge to pass our SQL statements in to the database, and then also to get results sets back from the database. And it really was a very effective, very interesting system to write. Well, the beauty of these things is it makes our distribution of systems and things like that so efficient. We used to have to, back in the really old days, go to everybody's computer and copy a file onto it, right? And then, of course, we got a little bit smarter, and we could copy the file down there by the network, right? Now we release a new version of the system just by putting a new applet on the server, so that when the web server directs you to that applet, it's a new release. You never even know that that there's been a new release, and the system gets better and faster all the time. The idea of anywhere, anytime access is really important. That it shows that if you're live in a place where the internet is not good, you're going to be on a lesser playing field. You're going to have to work differently than other people, right? And so all these things have been enabled by the technology of database connectivity, and what the internet has done for programming, and the speed of programming, and the ease of deploying programs is amazing. And I think we're just getting better and faster with all the new apps and things. The world is going to be a better and better place. We're on a great trajectory. But all these things are built on data. Whether it's an actual DBMS that's there, or if it's just going to be data in XML files, the skills that we're learning and that we are going to have coming out of this class are going to be important for all time. There's no doubt that what you learn today will be still valid in 20 years. Data will be data, and it will be managed however it is, but there will be relationships between some sets of data and no relationships between other sets of data. This is never going to change. Well, why is the internet a good thing? It makes our deploying things much more efficient, and we have built-in independence. Since we write for the web, write for the internet, that's someone else's job to make sure that it runs on the Mac or runs on a BlackBerry or what other device, right? And we get a lot of independence from developing our systems this way. And like I said, these systems are in place in many organizations, even though they're not open to the general public. They're still built on the same internet technologies. And then you also have the benefit of many people are familiar with the way the internet works. And so if you keep your systems consistent with the way other internet systems work, then you are in the situation where you reduce the difficulties of your users. You make it easier for them to use your system because it's consistent with what they already need to know. And again, you get some benefit from them not having to develop multiple platforms for multiple users. You also don't have to worry about where your users are, right? I mean, whether they're in your own local intranet, or if your internet includes the entire, or if you are reaching the entire internet, that is, your systems don't have to be any different, right? They may have to be more scalable, and you have other things going on behind it, but the where you are and where the system is and where the people that are using the system are is totally independent. Well, we're getting a lot better on our development tools and reducing costs. We still haven't tapped all of our benefits of distributed processing and scalability, but we've come a long, long way. And like I said, the trajectory is in a really positive direction. Well, the middleware is the part that really connects the system, that connects the application to the database. And on our group cognitive mapping system, what we did is we wrote a client applet that ran in the browser, and then we had this server-side extension, right, which was a Java program, a Java application that ran on the same computer as the web server, and then had access to the Access database through ODBC, or actually the JDBC ODBC bridge, and it worked really well. And I'll see if I can find that to talk about a little bit in our class, and you can see how simple some of those programs can be. So basically, we have this situation, right, where on our client computer, right, we have an applet, a Java applet. And of course that applet, what happens is the client computer makes a request, right? And then the applet is downloaded. So then the client runs the applet, and let's see. Let me see if I can run through this in like a series of nice little steps with a series of different colors. Let's see. So what should I do? We should start on. We'll start red and go green, go through. All right. So it starts like this. The client computer makes a request to the web server for the applet. The web server sends back the applet. Then the applet sends through the web server the log information down to the middleware, our Java application that we wrote, which then sends it on to Access, which then checks the database, which then sends back the results set to our program, which then sends back the results set to the client computer, or which is our applet. Now that the applet is approved, they are now one of, or part of the group cognitive mapping system. Then they do whatever, they send in the request for whatever. At this point, also, we have established a socket through the network. Let me get a different right after the log information is approved, we develop a socket between these two, between the clients and the server. So now the web server is not really involved anymore, and now we have a series of information flowing back and forth between them, the two clients over the socket. So now there'll be a request from the client computer for brainstorming. The Java application will receive that, then go down to get all of the comments or make a query. The SQL is here, right? Or the SQL is in the SQL is in the application that we wrote, right? So then it goes down, gets a hold of the brainstorming, or sends a query to the RDBMS. The RDBMS goes to the database and then returns our result set, which we then return to the client application. But we do something similar to what you saw on our previous thing, is that our middleware here takes these, all the brainstorming concepts to this point and puts them into a collection and sends them back. So the client, the applet on the client never really knows anything about the database. All the SQL and all the knowledge about the database is stored in the application in the middleware. And all the client computer needs to know is how to display the information that it gets and its objects. So here's sort of like a simplified view. Let me flip back to my highlighter. I think it makes do I want to keep purple? I sort of like purple. Well, so the client computer sends in the request to the web server. The web server then determines what type of request it is. If it is a call to the some sort of program written by us that then connects through the JDBC or the ODBC bridge or one of these other technologies to get to the RDBMS, and then the query is executed, and then back comes the result set, and back through the web server, back to the client computer. Note that there's 3 computers in this case. The computer for the web server, the computer for the DBMS, and the client computer. Well, so here's a slightly different perspective, and it is the perspective of using scripts. And the online survey system, which we will go through in a little bit of detail, is a system that uses a scripting, uses active server pages scripting to provide a middleware client. And what has to happen is the query needs to find all the questions and the possible responses for a section of the survey and display it on the screen so that the user can specify their answers. And so it starts out by a request from the user to so the user makes a request to the web server for our script, right? And then what our script does is it executes a program, a Visual Basic program that then goes to the database, and in this case it uses the ODBC link and then gets back from the database the questions to be displayed, and then it uses that database information, steps through that cursor to build this long HTML page which is then transferred back to the client computer and displayed in the browser because it's straight HTML. This is different than what we were doing on the group cognitive mapping system, where we have a Java applet out here on the client and a Java application as our middleware. That both of those that we've written. Here, what we have is a fairly dumb client, right? Doesn't know very much, because it's just going to take this HTML page and display it on the page and accept users' inputs into those HTML controls. Then pass back the response. All the smarts are in here, which is where the SQL and the processing to take that SQL and use it to build this HTML page is present. It all lives in there. Well, you all know what a web browser is. I'm sure you've used them 100 times a day. What it does is it takes in HTML code and displays it on your page. It allows many different components to be displayed in a standard way. It is in this system. Each client is displaying the page that it receives. The web server doesn't keep track of any of the things that are going on with the clients. Right now, in our group cognitive mapping system, the application we wrote was keeping track of all the clients that were connected and then sharing information with all those clients. But the web browser was only there to get things started and to pass information back and forth. It's sort of on the Java applet actually took over the page and controlled the frames and things with the real programming language. So there was no HTML and on those pages. Unlike the online survey system, which uses scripting. Well, the client-side extensions are programs that are written to do things right there on the, like sort of within the browser while the user is using the system. Now, if you think about it, what would have to happen is after the user was done, we would send our request back to the web server, which would then have it be processed by the application. But we might not know, or we wouldn't know, if that was our only way of programming, then we wouldn't know until the data got all the way back to the database that one of the data types was wrong. Right? So we want to be able to write code to validate our data and have it be executed on the web browser before the data are sent over to the web server side. And in our program, in the online survey system, we do this. We use a JavaScript. We write a JavaScript that takes, like, whenever the user hits submit, this JavaScript executes, and it looks at the responses for each of the questions to determine if it's a required question, if the user has actually answered it, and if it's like number, then they haven't entered in a string, like they didn't type in TEN for 10 or something. And that program, that JavaScript, we write that JavaScript into the HTML page with the online server active server pages before we send it back to the browser to be executed. But then what it does is all of our data validation it happens on the browser, so that when something comes from the browser back to the application, we can be sure, or fairly sure, that it is valid data. It should have already been validated. If it's not validated, it just means we have an error in our validation script. Well, so the web application server is sort of like the group cognitive mapping application that we talked about. What it does is it has a particular application, and you use it by connecting to it over the web. And in our case, it connected directly up then between the application and the applets using sockets, and then just passed objects back and forth between them. And so these services allow us to be able to have one system that connects to the database and other systems that manage their data from a purely object-oriented perspective, like on the browser side or the client. That's where things can be handled purely from OO programming without thinking anything about relational database. And some people see that as a strength. Well, they do have some potential that is for advantages that is not so easily attained in some of our other approaches. So we can have multiple services. We have a user authentication that then we can use on many different things. Like once we authenticated on the group cognitive mapping system, then you were in a connection pool, right? So we had a list of everyone who was connected and what their IP address was and what socket we were sending. Well, we always sent to the same socket, but we knew everything we needed to reach each individual connection, and it was very, very efficient. And so I think you'll see more and more services being provided as web applications. And it's just getting to the point where most people are going to start with this and then change to something else if it, for some reason, won't work. But now our technology has scaled and been tested well enough that in most cases it should work fine. Well, the point of the web-based development is to connect the database to the web browser. Right? I mean, that's what it's about. You know, in the online survey system, right? We essentially send the web browser an HTML page, and then the browser sends to us the data for the responses to those controls on the HTML page, and that makes our processing very simple. Well, that's about what we have in the terms of connecting our applications to our databases, and it's a very important idea. But you know, it's really just almost only a syntactical thing once you learn the concepts, right? Once you do it once you have a connection and you then make a command object and it has a query embedded in it and you get back your result set, after you do that a few times, the connection things become very trivial or simple until you have some kind of other problem. Like, well, one of the things we had was security issues, where to get the database to work right, we had to have that particular file be open to write in a directory that was open to internet users, and it was like a very scary kind of phenomena for me. But so the next topic is extensible markup language, XML. And what it is another way of representing data that is different from relational databases. And it involves defining the data with tags that are right in the data. So it's easy for the computer to understand what is being meant. And this is an evolution from the idea of HTML, right? Hypertext markup language. And you'll remember in HTML, you can do things like change the display of a text, right? You can say, okay, it's going to be bold, and so you have a bold tag, and then you have a font tag, and so then you have a bold, a font size, and so you can change what a string is going to look like depending on the tags. And you can just think of all the different HTML tags that you've seen. But that is presentation ideas, like beginning of the table, end of the table for displaying a table, is different than trying to describe the data for some semantic purpose, like to say that this is an order ID, or this is the order date, or this is the customer that placed the order, right? That kind of information is nowhere in HTML. And that's why we have XML, so that we can express those ideas or express the data in the way that we want to do it. We can create tags that match our situation. All right, so if we start with what's called a document type definition, and that tells us what our XML document is going to contain. It's sort of like our logical database structure. It's our create table statement. It is the thing that says these are the attributes that are going to be part of my table, and so what we do is we develop these documents, and then we share them with the people that we want to share our data with. So then we share this definition, and then along with the definition file, we share an actual data file, an XML file that has all the data that goes along with those definitions. Just imagine that there's a customer definition in one file, the DTD file, and then there's another file, the .xml file, that contains all the actual data from the customers in the format of that definition. So here's a DTD file, definition file. So we start off and we say that there we are defining a product list. We are defining a product list to consist of a product, and that plus sign means one or many products. And then we are defining an element that is a product that has a P code, a P description, a P date, a quantity on hand, a minimum, and a price. And then we go through and we define that each one of those elements are. Right? And we're saying that these are just string data. And hopefully you look at that, you say, well, I know that quantity on hand is not string data. Well, things have evolved somewhat on XML, and you'll see in a minute that now we have a way of handling that, right? This is, remember I said that XML evolved out of HTML. Well, this is one of the first evolutions of the evolution. And the next is schemas, but we'll talk about that in a few slides. So here we have our data. So what this does is gives us the definition of our data. Now the XML file itself, you see our extension here is .xml instead of .dtd, right? But here we say, right, we have a document type, it's a product list, and this is the file that describes or defines that product list. Product list.ddt. DTD, yes. And then, so inside this product list, we have a product, which has an end product tag, a P code, which has an end of P code tag, and a value of 23109-HB. And here we have a quantity on hand tag, and an end of quantity on hand tag, and a quantity on hand of 23. The next product, and so on. So the DTD defines the data that's going to be there. The code, the description, the end date, the quantity on hand, the minimum, and the price. And then the XML file contains the actual data. Now, interesting to note that here we have the minimum on hand, right? But here in this case, we don't have that data. We don't have that value. It's null. It's missing. It's just another way of representing the data. And remember, this is what's actually stored. This is a text file, and you can see that this slide was cut entering or by looking at XML file in Notepad. So to get the feel for where the or how the definition file matches up to the XML file, here's an example using order data. So here we have, and we define order data to be the order ID, the date, the customer name, the order shipped to, the ordered products, times, the ordered products, which is, that star means that it can have 0, 1, or many options. And so it's a multi-valued attribute there, right? Or it's a repeating group, I guess is what it really is. So you can see that this is not in first normal form. And we don't even say what is the key or anything. So we're not worried about that, right? What we're trying to do is have a way that represents our data, that makes it easy for us to define it and exchange it among different organizations and to process it in an automated way. And so if you think of what are the order data, here you can see that we have the order ID, the date, the customer, and the ship to address. But here, as we go down into ordered products, right, for each ordered product, we have the product code, the description, the quantity on hand, and the price. Same for the second product. And those match up to this part of the definition. So we have many ordered products for every ordered data. It's just a way of looking at it from a programming perspective. And the way you actually store your data on the disk is very simple, using your tags, your start and end tags. So your data definition document defines your tags, and then the XML document uses those tags along with the values of the data to provide a storage of the data. Well, XML schemas are the next evolution from the data document or document type definitions. And what you noticed when you were looking at those definitions, it was like, hey, they're all the same data type, and we know that's not true, right? We went to a lot of work to figure out that information and to know what was the data type of every attribute. We can't be translating from our beautiful database into some representation that doesn't allow any representation of data type. And sure enough, that's what everyone else thinks too. So we now have XML schemas, which are more advanced in terms of being able to specify all of the data types. Well, maybe not all of the data types that the database recognizes, but database that are data types that the database does recognize. So it is completely straightforward to map from your XML into your database. So here's a little bit of XML. An XML schema. And so here we see that this is the schema that we are referencing. And we create a schema element called order data with the data type of order. Now we come down here, we define a complex data type name of order, and then we add to that complex data type several elements. We add the order ID, which is a string. We add the date, which is a date. We add the order total, which is a decimal. But we also have this element ordered products, order underscore prods. And what that is a product list. And here we have we have the data type for product list, and we say that its only element is a product. And that product is a type of an A product, and it occurs at minimum once, and no unlimited max number of times it can occur. So this product is the element name in product list. A product is the data type of product. And the data type of product is defined by this statement, right? The things that go in this complex data type, right? Open tag and end tag. And within there we see that there are 4 elements for a product. The product code, which is a string and is required. The description, which is also a string and is required. The quantity on hand, which is a positive integer. And the price, which is a decimal. So as we stepped from the DTDs, I hope you see that these schemas are more useful, right? We are getting to something that is a closer definition to the kind of thing that we're interested in, because we are data-oriented people. Well, there's also, in addition to being able to store and represent our data, and for the purpose of sharing it, we also want to be able to present it. And there's extensible style language, XSL, that sort of goes along with the idea of XML. And what it gives us is the ability to transform XML documents, and then also use these style sheets to be able to make our presentation simpler. We know we're going to want to do a lot of presentation of this data, so let's try to make ways that make it easy. And so what a transformation does is it takes in this XML document, and then it can do a number of different things. You can see that it would be very easy for it to create a new document by doing some sort of extraction. To just say, okay, I know that a product has these 4 keys in it, but I'm only going to take out the first 2 keys, the product code and the product description. And I'm going to have a new XML document that is just those things, instead of just the description and the code, as opposed to all of the attributes, including the quantity on hand and the price. You can also convert from one set of tags to another set of tags fairly easily with a transformation, because you have coming in P code, and what you want is put out is product code. It's relatively simple. It's like taking this tag and substituting a new tag for it. The value of the data is still the same. Well, so then you apply these style sheets, right, to the data that you have in your XML files. So the transformation provides you with the data file to then display, and then it can be displayed either in HTML or on a mobile device. The idea is this whole process is separate from the actual device handling, which is handled at the next level down. Well, so here's what it looks like if you try to look at an XML document product in the or product list in a browser. You get a nice little hierarchy. You'll be able to see the codes. You'll be able to see that the product list starts at this code and ends at that code, and then you have a product that starts and ends, another product that starts and ends. You have a P code that starts and ends, a description that starts and ends with a value in between. And so that's what an XML data file will look like. So what you do is you take that XML data file, and here is an HTML. You can see there's an HTML tag just for that purpose, right? Say make me an HTML control, name it product list, and source it from this XML file. So then I come through and I step through this file one at a time, right? Start off with my table, right? And the start of my top, I put in an extra row, and then I have in the table column, I do a product code, description, quantity on hand, and the price. And that's sort of what it looks like. Well, lots of information sharing goes on with XML applications. That's how businesses share information. That's one way you can take data from a legacy system and take it out of the system, wrap it in or put it into XML with a set of tags, and then send it on to users so you can extend the life of some of your systems. You can also take input in a set of tags and then put those, translate those tags into something that the legacy system can handle. Now, to me, the strongest part of it is in information sharing. And we'll see a really great example of that if you take the healthcare data management class that I teach in the second summer session. And I think you'll find it's very powerful to see what it can do in terms of standardizing information like related to a health bill, an insurance claim. Well, cloud computing is an idea that other people can run the hardware better than we can, or if not better, at least cheaper. And then what we can do is focus on, instead of putting our resources on running the computers and backing them up and those things, we can spend more time thinking about what we really need. And then we also have some other advantages in that, suppose we don't make a good estimate of what we need and we end up needing more. Well, it might not be so easy to scale up depending on the decisions we made. But if we went with the cloud, that is a feature. That is, the ability to scale is a really powerful idea that brings people to the cloud in a big way. Well, so this is the idea, is that we have companies that are providing services in the cloud. We have Amazon, we have Google, of course we always have Microsoft. And so these are people saying, we can do things for you that you want to have. Do you want to have a relational database, but you don't want to have the DBMS server and SQL Server installed on it? Azure can do that for you. Do you want to stop doing your email yourself? Do you want to keep having all the servers and then the backups and the continual ongoing things so that when some crisis happens, you can reproduce all the emails that ever happened at your university or your business? Maybe you want to farm that out. Virginia Tech has farmed that out. We used to have on-site email, but last fall, I think it was, or last summer, they said everybody has to move to Google, right? So now my email, even though it says sheets@vt.edu, is actually really only a Google account. It has no real account here at Virginia Tech anymore like it did at one time. Now, it still works fine. I mean, I'm sure it's cheaper for Virginia Tech. It took me a little while to adapt, and still I have occasional problems. But I get it. I get it. Cheaper to acquire and cheaper to operate. Any business person ought to say yes to that. Well, so what type of implementations do we have? We have like the public cloud. That's where it's an organization selling a third-party activity to the public. We ought to be able to think of one like that. A private cloud is where an organization creates one just for the purpose that it's trying to do. It's basically using the technology of the cloud, the way the computers are organized, the scalability and all those things, to just do something within its own context. And then there's a community cloud that is based on what we do. We're military, and we need our own way of organizing and sharing our information that's restricted just to us, so other people don't have access. So I think what we're doing at Virginia Tech with our email is probably public cloud. It's a third-party organization selling services to us as a business, right? It's a business-to-business thing, but it is. I don't think they're operating just a special one for us. They probably have. They're selling email to many different organizations. Well, some of the things that you really need to have is this perfect connection, right? There, you need to really be always connected to the internet. there's a lot of in the implementation of these things. There's a lot of shared infrastructure that is used, and that's what allows the scalability. As one person is using a lot, maybe they drop down and a couple other people are using a little bit more, and so there's less infrastructure that's really needed because everybody doesn't really need it all at the same time. And so it's a very flexible, very scalable, and so you even have the idea of dynamic provisioning, meaning that you know that you're only going to need these additional servers for 2 months until this particular activity is over. Then after that, you're going to drop back. Well, you'll be able to upgrade without buying anything, really. You're really just sort of renting your time. And that's where the potential, some people believe, for these kinds of cloud services are to reduce everything to just a commodity kind of situation where there's any one system is no different than any other system. You want an HR system, just buy this one. You know it'll do everything that you need to do. Well, there's 3 aspects of the cloud computing that are, I think, really interesting. Software as a service, I think, is probably the most important. And that's where you're providing some application like customer relationship management or other types of business activities online for a company, so that they don't have to build their own CRM system, right, to manage all those kind of contacts and that kind of stuff. I'm not that keen on the Google Docs. We've tried them on a number of projects. They don't seem to work that well. I guess if my problem is I've never had an absolutely perfect internet connection at home, so it's really hard to do any of that kind of stuff that is shared documents. Well, you might also, instead of selling actual applications, like things that people can do, you could just sell them a place to put the things that they want to run, right? Do they want to run a web server? Do they want a relational database that they could have running somewhere and then build and then access it? Yeah, that sounds like a good idea, but they could put that would be giving them a platform to build their own systems on. And then the even lower level of that is the sort of infrastructure as a service, give you the ability to store files, help you to have flexibility in your access to your computing and things like that. I think the more and more things are moving to software as a service, and that's the idea of software being a commodity, once it's all been written. And who knows, I don't know that we're close on that yet. But when we are, what it'll be is jobs will be more about integrating different pieces of software rather than creating software from scratch. We're already reaching that sort of point. Well, all the wonderful advantages of cloud computing, how it doesn't cost a lot to get a database. You don't have to buy the computer. You don't have to buy the RDBMS software. All you just have to do is make a deal with someone who will provide those services to you. There is the idea of scalability. You can be built in automatically to your software, and you won't have to worry about that yourself. Load balancing, keeping things working, high levels of uptime, backup, all that kind of stuff is all taken care of. But then you have to have compromise. Nothing is free in computer science, right? If one thing is better, something else is most likely going to be less. And sure enough, if you have real concerns on your privacy and security, then are you really going to allow your data to be out of control? Right? In a way, it is out of your control. I mean, unless it's it's also being mirrored on your own disk or something like that, then it's in a different place. Are we really capturing all the different costs? That initial cost is one of the reasons we say it's a big deal. Now, if you're worried about all these risks, what does that lead you to do? That leads you to start writing more and more complex contracts to try and eliminate those risks. And that makes your job harder too. Then finally, I guess you have a little bit more cost of integrating with your existing systems if you go this way too. Well, I think SQL data services, where what you get is relational data management over the cloud, has a lot of potential. I think that these ideas of how databases are accessed and used makes a lot of sense to go through the cloud to do some of these things, and it'll be interesting to see how many systems in the future feel like that they can do this. You're losing control, I think, is the main issue as you turn over more of your activities, like your relational database. Now you are really dependent on the people that you are putting your data with. Well, today we talked about database connectivity. There's a number of different ways to connect, and it's middleware. It sits in the middle between the application and the DBMS, and it just takes in the SQL statement and then passes that to the DBMS, then takes a result set from the DBMS and packs it back to the client. And there's just a number of different ways to go about that. One of the things that we really are striving to provide is this idea of universal data access, so that we can always have access to our data. And I think this is going to get better and better over time. Most systems do have some sort of native database connectivity, some way of connecting to directly to the database, and a lot of times these are optimized by vendor. We also talked a little bit about Oracle. So the object embedded databases, the goal of these things is to try to provide access to object-oriented programmers in the way those programmers like to look at the world. Not so much in the correct way or the relational database way, but in the way that programmers like to look at the world. And I have no problem with that, and that's really what the three-tier architecture that I hope you learned about in software engineering, it becomes really important, right? That we are separating the problem of displaying this solution from the problem of solving the problem, and from the actual storage of the data needed to solve the problem. Well, the main thing on the middleware is that it's what contains the SQL or the ability to access the database, and in the web browser on the client, we're trying to keep that as dumb as possible and try to limit the work it does. But we have to have it do some work. Like I talked about the JavaScript that in the online survey system validates the entries to make sure that you've answered all the questions that you needed to is really important. And so it saves a lot of network traffic and things like that. And finally, XML is the way that we share our data, and it's a really, really big thing, and its power is in its simplicity. What it says is you can define any data type to be a start and end point tag, and then within that you can put any hierarchy of data tags. And so understanding how XML works and that it can be translated, we can take our database and translate it into an XML format very simply. All right, well, that's all I have for today. I hope you have a good rest of the day. See you in the forum.